The second function we have is, so I will open and go to my type and open my function and go and choose below and do it and put it here inside. Current 3-phase. And I will go to the bottom and choose and do it and put it here inside the feeder protection. All right. Okay, I will come and click here on my function, just like I have a set of things I can add whatever I want, whether it is or whether it is. Okay, I will work on just one just to see how its setup looks like. Okay, now I have two parts here. There is a part related to under voltage and something called general. Let's handle the under voltage part first. It tells you if the function is on or off. You will say on, and it will ask you if the operate and default recorder is blocked. You will say no, and it will ask you if it's blocked by the measured voltage failure, which is through the VT fuse failure. If you have a VT fuse failure and need to block the under voltage, you will tell him yes with under voltage, and I actually have active fuse failure, the measured fuse failure, and the binary input of the VTMCB trip. Measure face to ground or face to face, work under voltage, face to ground or face to face, depending on your application. It comes here and asks you about the measured value, whether you want face to ground or face to face, meaning should the under voltage work on face to ground or face to face, depending on your application. Then it asks you whether you want the fundamental component or the RMS value. After that, it tells you about the backup mode, which will depend on the choice you made for the measured value. The term 1 out of 3 means phase to ground, meaning you will approach VAN, VPN, VCN. In backup mode, when you say 1 out of 3, it means if VAN, VPN or VCN experiences under voltage, it should trigger a backup. 3 out of 3 means that VAN, VPN and VCN must all have under voltage for the backup to be activated, as it requires an AND gate with all 3 phase to neutral voltages. Okay, if I choose face to face, 1 out of 3, we'll read which ones: VAB, VBC, VCA. 1 out of 3 means VAB, VBC, VCA, and 3 out of 3 means VAB and VBC and VCA. Order, and it means the AND, right? So this setting is related to the previous setting. Which one? Great. So it depends on your application and your requirements. It will ask you if you want or don't want something, for example. Then it will ask me how much your requirement is. Here, this number will depend on what you set above. If you told it that, then you need to know what its normal value is. 120 on device 3 based on what we know. This means that the phase voltage is 69.28. So when you come to set the under voltage here, which is, for example, 80% of your quantity or 90% of your rated voltage, it becomes 90% of the phase voltage, which is 69.28. If you have selected face to face here, then you must choose face to face here, meaning that your measured or rated value is 120 volts. So when you set it to 90% or 80%, it becomes 90% or 80% of the face-to-face voltage, which is 90% of 120. If you set it like this now, for example, 100 volts, great. You set it to 100 volts and you selected face to ground here. This means that under normal voltage, you will have under voltage. Why? Because the value it measures now is less than 100. So here, your setting is not automatically programmed based on what you selected. No, you have to set it yourself. Since I chose phase to ground, I would set it here. For example, to 55 volts. Okay? Always in under voltage and over voltage situations, you find something called your setting or your threshold. For example, you have it set at 55. If the voltage drops to 54, it triggers. If it rises back to 55, it resets. No, it must return to the original setting. That's why it gives you a stable dropout ratio that you set yourself. So for example, it must reach 110% of the 55V value, meaning it should exceed 60V, or 105% of your threshold value. Lastly, I have the operate delay time exceeds 60 volts, meaning or 105% of its value. And finally, of course, I have the operate delay time. Great, so far, so good. Now, where is your VT located? Either on the line side or on the bus side. Is that correct? Nice. Okay, if it's located on the line side and you were talking to me about a feeder, for example, going to the load, so that means as soon as I open mine, it will immediately read, and thus it will have a condition. All the time, it will be in a 0 voltage state, so it will have a condition. Okay, so here it tells you if you have the VT, for example, on the line side, So what can the condition do for you? It can make it so that I don't need to keep doing it. It will keep working with me and won't stop. Or remain in a state of, or what do you have? We can go into our system and look for the specific under what, the under, here for example, this, we can go to our website and look for the section related to the under what? The under voltage. Here for example, this is over voltage. And this is the topic of under voltage. We will go to explain the topic of under voltage and see the subject of our decision. This is the topic of the function, and this is the subject of our decision, 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 and this is the sub. All right, so what is it telling you? It's telling you that if you turn it on, if you activate this function, it means that if you turn it on and the current drops below a certain value, it means that laser. You can use the current flow criteria to make the pickup drop out when the current falls below a minimum value. It means that if you turn it on and the prosperity of your current drops to a certain limit, it means that it will be, you don't have a current passing through now, which means everything is off. So don't let the function ICAM trip. If you turn it off, in the case of under voltage, the backup of the under voltage protection stage persists when the current flow is not used. This means if you don't have the current flow criteria set and the under voltage is active, even if there are no currents, it will work just fine and won't depend on any currents in any way. Is that clear? Good. Very nice. So let's go back to my function here. If you set it up, it will be just like that for you. Okay, now I want to go and program mine. I go, as usual, to my place, and of course, I had programmed before with the other function. So I will do it for that and for mine. And delete the one that comes and delete the one that comes. And here, for example, in the input scan, for instance, there's programming done for it. I will definitely remove it because we are publishing it from the Zadian. All right, you will delete any function, even delete the function that I programmed with the main menu that we will return to later. So I open the under voltage, same thing. You want to make a backup and drop off and trip time. So you go to the same function, the stage is the same, and you go and open the pickup. You have pickup phase A, B, and C, okay? And you have pickup loop A, B, B, C, and C, A. And here you have the operator. So you program 3 data here, 1 with data A. I go here to the data. I program here with data A, okay? And I program it with data B, okay? And I program it here. Here it is. The LED with phase C. And I come to the output contact of this operate. I program here output contact 104, for example, with the A. With the thing, okay, this is under voltage because it will work. Okay, the under voltage is supposed to be achieved, for example, through whom, through the thing. Okay, where is the thing, or through the thing? Okay, where is the thing? 8. All right, so now I will look for the power system here and go to measure point voltage. Okay, and go to something called VT miniature circuit breaker, because this VT feeds the function, so this VT comes through the MCB. So this MCB, I come and program a specific binary input. Let's assume, for example, 2.1. And I come here, of course, this is because what I am doing is wiring. So I chose 2.1 and I set it to active high. Like this, I program my function. And then I can send it so that I am ready for the test. I input my data and now we are ready for the test.